Okay, so welcome back. Today we are covering the chain rule again. This is our second day on the chain rule. I didn't say this on the first day, but the chain rule is the most important derivative rule that you will ever see. More important than product rule, more important than quotient rule, more important than power rule, because the chain rule allows you to take derivatives of compositions of two functions. And so it just really expands the things that we can take derivatives of. So we'll spend all of today continuing to talk about the chain rule. A reminder, test corrections are due on Friday. Also on Friday, I'm going to pass this piece of paper around, and this is where you're going to tell me how you want me to calculate your grade at the end of the semester. This percentage of homework, this percentage on the tests, this percentage on the projects, okay? The guidelines for how I calculate your grade are in the syllabus, so just make a choice. You have now all the numbers in front of you on that test that I just handed back, and you know how much time you have to commit to homework or projects or, you know, like attendance or whatever. So make a choice. I'll ask you to fill this in on Friday, okay? All right, so back on page 7, here we are. We're actually going to do 3 and 4 before we do 1 and 2, but let's start with the summary. Can we go to Tyler for the daily summary? Okay, so let's jump down to 3, and then we'll go back up after. Petru, could you read 3? 3. The derivative of stuff. Okay, so let's try finding the derivative of this y equals e to the sine of 2x minus 4 cubed. It's the most complicated function to date that we will take a derivative of. Now there are a couple of derivative rules that we don't have yet officially, so I will tell you that the derivative of sine x is cosine x. We'll see that soon enough. And the derivative of e to the x is itself, it's just e to the x. So let's find the derivative of this guy. So we'll use our good notation, dy dx equals. Okay, so the main function that I'm looking at here is e to some stuff. And according to our second fact here, what's the derivative of e to some stuff? It's just e to that stuff. So we're going to copy e to the stuff. The derivative of e to the x is just e to the x. So the derivative of e to this complicated thing is just e to that same complicated thing. But then times the derivative of the stuff. What's the stuff at this moment? There's that sign. Okay, so that's the main idea from the chain rule from last class, is you apply your ordinary derivative rule, but then at the end you multiply by the derivative of the stuff. And why was the stuff all that sine and 2x minus 4? Because normally our derivative rule is just for e to the x. So whatever is up there, if it's anything more complicated than x, then that's the thing that we have to find the derivative of. And it was all of this. Okay, so let's keep on going here. So I'm going to copy this first part just as it is. And now we're going to find this derivative that's requested. So it's the derivative of sine of something complicated. Again, it's a rule we don't officially have yet, but we need to use it. What's the derivative of sine x? It's cosine x. So what's the derivative of sine of this stuff? Is cosine of that stuff. So that's how we move on. So the next part is cosine of all this stuff. Normally, derivative of sine x is just plain old cosine x, but if it's sine of something complicated, then it's cosine of that complicated thing times what? And derivative of the stuff, right? This is another chain rule here. It's not just sine of x, it's sine of something complicated. What's the stuff now? That's right, 2x minus 4 to the third. It's the thing inside of our sine function. We just keep grabbing the thing inside of our original function. Okay, so copy down the first few factors here. So copying everything up to the point where it says take another derivative. And now it's time to take this derivative. And at this moment, if I kind of cross my eyes a little bit, all I see is some fancy stuff to the third power. Yeah? And so if it was just x to the third power, I could handle that. So I'm going to handle this in the same way. If it was just x to the third, what would the derivative be? 3x squared. But now it's this stuff to the third, so what's the derivative? 3 stuff squared, right? So the next piece is 3 times the stuff to the second power, right? It's like 3x squared. It's just more complicated than x. And then times derivative of 2x minus 4. Right? If it was just x cubed, we'd be done. But it's not just x cubed. It's 2x minus 4 cubed. So we've got to pay for that with this chain rule. All right, I'm going to get lazy because I don't feel like copying all of this stuff one last time, but let's just write the answer here. What's the derivative of 2x minus 4? 2. So the entire answer would be blue times the red times this black times the green 2. That's our answer. Questions on that? It's okay if it's a little bit overwhelming. These multiple chain rule things tend to kind of telescope out. Something small becomes more and more complicated as you work your way from the outside to the inside. But we just go very slowly and we take derivatives one at a time. I will say that you don't ever have to show me, you know, this times the derivative of that stuff and then times the derivative of that stuff and then finally the derivative of that. You can just write the final answer if you're comfortable doing that. And I suspect that with a lot of practice, you will each get to a point where you're comfortable just kind of mentally updating what's the new stuff right now and what's its derivative. So ultimately, I just need you to get to this final answer any way you can. All right? Okay. So if we got this done, let's go back up to the top and take a look at let's go to number 2. It says we have two functions, f and g, and then we have a bunch of like data points for f and g. F of 1 is 4 and f prime of 1 is -2. And then we have some more information about f and g, okay? So all we have is isolated data. And what we're going to do is this find the equation of the line tangent to this new function. H of x is some third function. And this third function is 4 times f of x squared plus g of x, the whole thing squared, minus f of g of x. Some complicated combination of f's and g's. And we want the tangent line to that new complicated function at x equals 1. All right, so this is going to push us. This is a tough problem. Okay, in order to find the equation of any line, I generally need 2 things. What 2 things do you need to find the equation of any line? Slope and a point, right? If you have the y-intercept, then that's great, but any point will do. Okay, let's find the point first. So we need a point that's on the graph of h. What's the x value that we're interested in? 1, that's given in the problem. How do we find the y value? Plug 1 into where? Into the equation of h. We're trying to find the y value on h, on this new curve. So we're going to find h of 1. Okay, so let's plug 1 for all of those x's. So it goes 4 times f of 1 squared plus g of 1, the whole thing is squared, minus f of g of 1, right? Just change all those x's to 1s. Okay, so let's do some calculating here. This is really asking for f of 1, right? Because 1 squared is just 1. F of 1 is one of the few pieces of info we're given. How much is f of 1? It's 4. So the 4 gets copied times another 4, because f of 1 is 4. Plus, now it's supposed to be something squared. G of 1 is, again, one of the few things that we're given. How much is g of 1? 2. So that guy goes there. Minus f of g of 1 is, again, there's still 2. And so we just patiently run through these calculations until we have a number. 4 times 4 is 16. Plus 2 squared, that's another 4. Minus f of, what did I miss? Minus f of g of x. Yeah, it was minus f of g of x here. And then at this stage, we changed all of the x's to 1s. So that's why this guy became a 1 in here. And g of 1 is 2, right. F of 2 is 7. It's, again, one of the few things that we happen to be given. All right, so that f of 2 goes right down there. And now finally we can crunch through and get a number. Is it 13? Okay, so that means that a point on the graph of h is what, comma what? 1, comma 13. All right, so I don't think that's hard. It's really just a matter of carefully working your way through each piece. What was the other thing we needed to find the equation of a line? Slope. And in this case, it's a tangent line. So how do we find the slope of a tangent line? So we take a derivative. This is the hard part. So let's see if we can find a derivative of h, the equation that we're interested in. Slope says find h prime of x. Ultimately, I want h prime of what number? Of 1. It's the same x equals 1 that we're still interested in. But before we find h prime of 1, we need to find h prime of x. Then we'll plug 1 in. Okay, here we go. H prime of x equals. I'm going to start at the end of the h function. I'm going to start way out here. It's minus f of g of x. In order to find the derivative of f of g of x, well, that's exactly the formula that we introduced last class, and I think it's just above, it's just off screen here, right? Don't you have a derivative for f of g of x? We can just read it off from that line up above. So this guy comes down here and becomes, what's the derivative of f of g of x? Everybody see where we got that? That's one symbolic way to write the chain rule, and it's exactly the derivative of what we want, f of g of x. And that f of g of x was following a subtraction sign, so we know that addition and subtraction work very nicely when we're doing derivatives. So whatever we get in the front, we're just going to subtract that thing, f prime of g of x times g prime of x. Okay, now it gets tricky. So before we look at the rest of h, let's just remember that we can think of f of g of x as being an outside function and an inside function. And the basic chain rule in terms of the language outside and inside says you take the, is f the inner or outer? Outer. You take the outer function and you find its derivative, yes? And then you take the inner function and you copy it, right? So it was the outer function's derivative, inner function copied. Then it's a times. And then which function do we go to a second time now? Is the inner function, and we put its derivative there at the end. That's what those symbols break down to in inner and outer language. So let's do the same kind of thing with this function. Okay, so first of all, that's a 4 times. Constant multiples stay or disappear when you take derivatives? Stay. So we're just going to start with a 4 times. It's a different color here, so we're going to now do the derivative of this guy. 4 times. Okay, I have f of x squared. That's really two functions composed with each other. F is the inner or outer? Is the outer. X squared is the inner. So we're just going to do the same kind of f prime, g prime of x stuff, just with those two functions. So f is outside, x squared is the inner. Okay, so the derivative rule said we take the outer function and write its derivative, right? So the outer function is f. Symbolically, what's the derivative? F prime. So it's 4 times f prime of, yeah, now coming back here, we saw that the g of x just got copied right down inside here, right? So what's going to get copied right in here is the x squared. And then we're continuing the chain rule. Next thing in the chain rule is times. This is the derivative of which? The outer or the inner? Inner. So it needs to be times the derivative of the inner. Times, what's the derivative of the inner? 2x. That right there is the derivative of what's circled. Just kind of playing this game with outers and inners very carefully. Okay, we'll change colors as we move to the last part of this derivative. I want the derivative of g of x, the whole thing, squared. So I see g and I see squared. Which one is the outer function? It's the squared, right? The entire g function is being squared. G is literally sitting inside of the square, yes? Which means that in this first part, like it was the x squared was the inside part, but the squared is outside in this case. And so they kind of change roles here. So we know that the inner part is g and the outer part is the squaring function, like x squared. So we do the same thing that we did before. We know we're supposed to take this outer function and find its derivative. So the outer function is the squaring function. So what's the derivative of x squared? It's just 2x. So we're going to put here, see there's a plus sign, 2 times, now it's normally x, but in this case we know that we're not just supposed to put x inside of the derivative, we're supposed to copy the inner one in here, yes? So what are we copying in here? Is g, the thing that's inside. Normally this would just be 2x, but it's not just f prime of x, it's f prime of whatever the inner function was. So we need to put the g of x right in there. And then we know the rest of the chain rule says, okay, times the derivative of the inside. So right here needs to go times the derivative of the inside. This is just symbols. What's the derivative of the inside? G prime of x. Times g prime of x. All right, so things have gotten a little bit smushed here. I'm going to kind of carve out the slope calculation. So that whole thing right there is the derivative of h. This is the green stuff plus black minus red. That's h prime of x. The rest of this is mercifully straightforward. That's the hard part right there. And it really takes some time to get a handle on this whole idea of inner outer. What value of x are we plugging in? 1. So that means that all of the x's become 1s, and literally I would write them all and just copy this whole thing again, but all the x's become 1s. That line that I just wrote is better not to look at it. Like, don't copy it. Just rewrite your previous line with 1s for all the x's. Okay, and then I think we have all the data we need to do these calculations. So this is saying 4 times f prime of 1. How much is f prime of 1? -2. It's off screen for me, so if you see an error, let me know. Times, and then there's a 2 times 1, so that's just 2. So far, so good. Plus 2 times, what is g of 1? 2 times, what is g prime of 1? -6. Again, if there's any mistakes in these, let me know. Minus f prime of, I'm just going to copy that part. I need g of 1, that's still 2, times g prime of 1, that's still -6. And so there's only one other function call, this f prime of 2. How much is that? F prime of 2 is 7. Prime of 2 is 10. Thank you. And now we just do the arithmetic. So let's see. -16. Is that -24? And then plus 60. I got 20. Okay. Any questions on that calculation? Not easy. So then finally, it's time to write the equation of the tangent line. So I'll start with phi equals mx plus b. We have the y value at a certain point. What was the y value? So the y value is 13. Equals, the m we just found is 20. The x at the point is 1. So we now can find the y-intercept. So I get the y-intercept is -7. Anybody else get that? Okay, so if there are any questions on here, we'll just leave this projected for a little while. I can walk around and help out if anybody got stuck. There are a lot of details in this calculation, but go ahead and move on to the activity on the next page. You'll see a few multiple calls of the chain rule examples. Then you'll see one example like this, and then you'll see a problem about a dog and calculus. So let's see how far we can get.